now. Okay, very well. Thank you, Ryan. Thank you, Daria, for all the support during this conference, and everyone here. Welcome to this conference. My name is Enrique Romero Mota. I'm a supply chain designer, senior consultant in Decisiones Logísticas, with a well-known Colombian company. Let me show you a little bit about the company, and then I will talk about how I'm going to present, this business case. And Decisiones Logísticas, it's a company with more than 25 years of experience providing logistics solutions in different areas with different industries, even manufacturing, services, agro-industrial businesses, and of course, food industry as well. So this business case is one of these cases that we already faced in the previous year, and it's focusing, on the food industry with one of the biggest Colombian companies in that industry. Okay, I divided the presentation in three main topics that we're going to discuss with some detail. The first one is related with the challenge we faced during this project. The second one is related with the way we used anyLogistix. And the final topic will be related, with the final results we achieved using these tools and everything related, with this supply chain design. Very well, let's moving forward to the first element, and let me highlight you a little bit with the challenges we faced during this project, okay? So we have to switch the company's name because of a confidentiality element that we have to respect. So that's why we already provide you with a fictitious name, which is Don Josue, which is like a fictitious name. So let me tell you about the challenge we already faced, okay? First of all, we are working with one of the biggest company in Colombia, as you already see here. Let me show you right there. There is an interesting topic here about the customer's localization, which is, over the country. So as you already see, we have customers in the farthest places in the country. So that's the biggest challenge we need to face, how to create a strategy, for managing the distribution, even considering, the dispersion of the customers, as you can see right there. The company has 4 sales channels: wholesalers, retailers, institutional sales, and department stores as well. 450 SKUs, primary dry cargo. And also we already aggregate a little bit, in order to simplify the modeling stage. We already aggregated products into 12 product families. And let me show you a little bit how this supply chain works, okay? We already have a kind of a raw material supplier and some, let's say, first stage warehouses, then factories, then another warehouses for managing the final distribution, and then we already got the sales channels, retailers, wholesalers, institutional sales, and so on. Okay, as you see right there, this supply chain has an interesting element right here, which is complex network. As you see right there, that's a lot of flows, a lot of combinations, that we must take into account, we must consider if we want to optimize the distribution strategy that the company wants to, let's say, use. So we already have 11 factories, 550 cities to be attended. Each factory can produce different SKUs, and this is an interesting challenge, related with that. And not every single factory produces the same products. So the mix in every factory was a little bit different, okay? Another challenge, to the supply chain complexity. 8 distribution centers, and a new factory opening in 2024. So we must include everything, in a model. And we must deal with everything if we want to provide, a specific strategy for managing the operations. But we must provide a solution not only for the current year, but also, we must provide a solution for the following 10 years, which in the first side sounds a little bit extreme. Why you want to do that? Why you want to, let's say, create a sales projection over a long horizon planning? Well, that was, let's say, one of the biggest challenges we already addressed, how to manage this operation in a really long horizon planning, okay? And let me show you a little bit how we did it. What will be, let's say, the solution approach we already developed for handling such complex network. Indeed, this complexity led us to think what will be the software that will help us, to develop a quite interesting and viable solution for our customer. And that's why, that was one of the reasons we already choose anyLogistix, because we must use, let's say, a top level software, for managing the complexity already mentioned here. So let me give you some highlights about the way we approach a solution to this big problem. So we already divide the project into 3 phases. The first one was focusing on understanding, the supply chain, understanding how the supply chain works, what was, let's say, the biggest challenges that the company addressed so far, and also try to understanding the demand, one of the main inputs of every single project on supply chain design. And then we already move forward to the modeling stage, the modeling phase, and that phase, we already create a baseline, and then we're already planning some scenarios, for testing different things, try to find better ways to be, better ways to do the distribution itself. And also we try to, from that scenarios, try to create, and came up with a proposed strategy, which is the last stage. We call that the implementation stage. And that stage was focusing on creating an action plan that be implemented in the short term, from the company. Okay, so let's move forward into these 3 steps. And let me show you how we used anyLogistix during these 3 steps, okay? So during the first step, which was focusing, let's say, on understanding the supply chain, we of course need a really top of the level software, for managing this complexity. I mean, makes no sense try to do this in Excel. It's too complex, too big, the change, too many elements, too many variables for considering these small solutions. The complexity is really high, so we need a solution that is capable, of giving us in a let's say right amount of time and optimization solution and everything related with that. I mean, we are not willing to wait, months for getting a solution here. We must work in this project during 6 months. So you can imagine we need to create or even produce solutions faster. That's why, we decided to work with anyLogistix, because this software provides us the perfect elements we need to develop and test a little bit, the strategy for managing the whole distribution of this company, not only in 2022, was the previous year, the project was done in the previous year, but also from the following 10 years, even in a really long plan horizon, as already mentioned, okay? So we already work with 2 experiments. Probably you already know how anyLogistix works. You know that anyLogistix creates a kind of different experiments in the different presentations during this conference. You already saw that. So we focus on main 2, which is the Greenfield Analysis and also the network optimization experiment. We want to create an optimal strategy and understanding how this strategy can be implemented, okay? We're already not focusing on simulation. Probably some of you can think a little about why we don't use simulation for testing and stressing, let's say, the current strategy we want to propose. And primarily was focusing a matter of timing. Okay, we need to deliver this project in a really, really short period of time. And we already work with a really, let's say, very demanding, calendar, for getting deliveries and findings and everything related with the project. Okay, so we already work with that. We're with the Greenfield experiment in order to understand a little bit new potential distribution centers that can help us to, of course, minimize the distribution cost while keeping the service level intact. And also we already network optimization experiment and to obtain the optimal configuration for handling the demand over the planning horizon, which at the end was the main topic we want to do during this project. Okay, so let me show you some elements that we already found using anyLogistix during this case. So first of all, we already analyzed the way with the demand will behave, and we already found some interesting insights about it. First of all, the company wants to introduce new products, and probably, sounds a little bit easy to move, let's say, with the supply chain, with the current supply chain. But the problem was related with the way with the, these new products will behave in the near future. I'm talking about the way that these new product categories will increase its participation over the sales portfolio that the company want to present in the following 10 years. And when talking about, an increment of 200% over the planning horizon, which is really an interesting number. Of course, these new product categories wasn't the first one, wasn't the main one that the company wants to move through the current supply chain. There are two main categories, as you already see right there in the chart, that will represent, around 75% of the whole portfolio. Okay, but these new products also represent an interesting, an additional, let's say, challenge to consider when you want to develop, supply chain strategies. Okay, so at the very beginning, we already understand how the supply chain operates. What was let's say, the main topics, and that's why we're starting with a network experiment. In this network experiment, we created the baseline. Of course, for doing that, we already setting up some constraints, even production constraints, even some transportation constraints as well. And we already, established, let's say, the first site, the way that the supply chain works, okay, in a current way, the actual way that the supply chain works for managing the distribution. And we already test that structure for managing the planning horizon, okay, the 10 years, the planning horizon, and we already find out some interesting topics. The first insight was related with the way the new factory will affect, the logistics and the supply chain flows. And it was an interesting insight, as you see right there in this graphic. We already check here in a scale percentage, the baseline logistics cost, and we already noticed how the new factory, decreased in an important fashion that logistics cost, something like between 20.2 and 3.4, percent, which is a really important amount, considering the business, considering the supply chain, and of course, considering the Colombian industries. That is a really, really huge savings, but not created because of our own strategy. I must be clear with that, that fact was led, let's say, by the fact that in 2024, a new factory should be opened in the north side of the country, in a place called Barranquilla, which is close, let's say, to the Caribbean Sea. And I'm going to show you right there in a map, so you can locate it easily, the place that this new factory will be open. And of course, that effect represents an interesting way to let's say, reassign, the flows from production to transportation to distribution, and of course, finally to the end customer. And we want, of course, to create a strategy that can support that fact. Okay, so after that, once we already create that baseline and understanding some whereabouts about it, then we are starting with the Greenfield experiment, as you see right here. With the Greenfield experiment, we already test, some potential locations for new distribution centers that will help us a little bit to improve the service levels and, of course, minimize the total distribution cost. Then, we already check the current locations, but just from a, let's say, demand density perspective. Remember that Greenfield experiment doesn't take into account costs. So we're focusing only on the way that the demand behaves and how, these distribution centers should be located. Okay. At the first site, we already found 3 new potential centers located in Boyacá, Caldas, and Quindío Let me highlight you a little bit, something like that. These ones are the new ones, and the actual ones created, let's say, with the red label. Okay, and I'm showing just the distribution centers and how those distribution centers were spread over the country. And the new factory, will be open in 2024 here, which is in the north side of the country. Okay, and the other factories were located here in the center of the country. A little bit, let's say, far, let's say, from the other factory. But the point is, we are working with a multi-factory environment, which means, that not every single factory should produce every single product. Okay, keep in mind this, because at the end, we are going to see how this fact change our strategy in a really important fashion. Okay, so once we already created the Greenfield analysis, then, we already modeling different scenarios. Those scenarios were focusing on changing and relaxing some constraints, focusing on production, focusing on distribution, and understanding a little bit, how we're gonna, let's say, prepare a final strategy that will be viable and, of course, will support what the customers want. Okay, then let me show you some results we already achieved with those scenarios. So here we already checked some interesting elements, and as you see right there, we already made the comparisons between the baseline and an end scenario without constraints. We already relaxed most of the, almost everything single constraint that we can do it, just to understand what will be the, let's say, the optimal configuration and how different will be that configuration from the current one. So we expected a little bit to, to see some big changes, of course, and understanding what will be, let's say, the improvement points. We call this inside with our work team, the hot spots, from the supply chain, that points that we need to focus on for making the biggest improvement. Okay, for, let's say, using that as a start point from our proposal strategy. Okay, and of course, as you see right there, we already achieved quite interesting results. Once again, we're seeing the logistics cost in a percentage scale, and see that we already reduced a little bit with this optimal one. The logistics cost as well, something like 2.2 or even more in some years, as you see right there in 2027, something like 3 points, and 2028, something like that, pretty much the same. And as you see right there, well, the optimal configuration was quite interesting, but some of the elements that this optimal configuration has wasn't possible to implement, okay, because of some physical constraints and some legal constraints even, and some elements that we need to address, before moving from the scenario stage to the last one, okay? But we already made an additional analysis, which was a really interesting one. And we already, let's say, discovered some interesting insights using anyLogistix for that purpose. Because, at the end, when you run a network optimization experiment in anyLogistix, you're going to get not only the product flows, but also you're going to get the production flows as well. Okay, and with the production flows, and also you are understanding, if you are including, of course, production facilities in your network, how let's say, the production will be reassigned. And that's why, and precisely that point was one of the most important points we want to work with. Okay, so let me show you a little bit what we find in that element. Okay, so as you see right there, the production quantities were quite affected because of the production cost. So we decided, let's say, to relax the production constraint. I'm talking about the production cost. We are not using, in fact, the production cost itself, but the differential production cost, which is, the way that every single manufacturing facility will produce and at what cost each facility can do it. Okay, each production facility can do it. Okay, so here, for instance, we already notice a big difference in production levels when we relax that constraint. And what's interesting, to notice that, because one of the biggest challenges that this company has is try to control, their production cost. And precisely because their production cost, primarily were affected because of the raw materials cost acquisition, So that will lead us to one of the biggest conclusions during this case, and was related precisely with the way the company should work closely, with developing, let's say, the upstream of their supply chain. Okay, so as a conclusion, right there, we already state a quite interesting point. Anything that changed the production cost must be managed carefully. Okay, and remember that we are working in a food industry company that primarily process, let's say, products from the harvest, and then process in the factories and so on and so forth, and then move that to the distribution channels as well. Okay, so that's why that finding was really, really important. Okay, and was the biggest elements we need to address from our proposal strategy. Okay, then we already moved to some distribution scenarios, try to understand a little bit how we can change the configuration of the network, in order to get better solutions, in order to get, let's say, better alternatives. And then with all of this information in hand, we can create our proposal strategy. Okay, so what changes we made for doing these distribution scenarios? First, we added the new disease, accordingly with the GFA experiment results. And then we already changed the inventory policies as well. We already handled that. Remember that we're working in a network optimization experiment, so inventory must be taken carefully. I mean, I'm not talking about dynamics in this case. I'm not talking about the real way that the inventory policy will affect, let's say, the supply chain process as well, because we are not using simulation. We already use network optimization, but we want to know a little bit, the effects of inventory on the whole supply chain configuration. Okay, that's why we already use some elements related with the product storages and everything related with that, for taking into account, the holding cost, the holding inventory cost into our modeling. Okay, so here we already see the final results, the savings and overcost. And keep in mind, if we address, if we take into account additional distribution centers, of course, in this case, we're going to get an overcost related with the warehousing cost, which is expected, of course. And also we're going to get some, we're going to experience additional inventory cost as well because of the new units we want to work with. And of course, that help us a little bit to understand better, the supply chain network. Okay, then we already find some interesting savings from a transportation perspective, and that's why we focus on. Okay, as you already noticed, we already found out an interesting savings even from transportation to customers and transportation from factories to warehouses. We call this T1 and T2, and also we already understand that adding these distribution centers could lead us to a better solution probably, and to a reconfiguration of the whole supply chain network, but also, to a better behavior as we expected right there. Keep in mind that we run the model based on some assumptions. One of them was related with the way we satisfy demand. In this case, we're already working with a 100% of demand satisfaction. We're not, let's say, leading somehow with some variability and something related with that. And we are not focusing on understanding if something changes, how the service level can be affected. No, we are focusing on satisfying the whole demand and how we can do it in the best way we can. Okay, that's the main focus of our business case. So here we already take the information from anyLogistix, and we already make some additional analysis related, let's say, with how many, let's say, how many space or how many additional space we're going to need, for managing the whole thing. In this case, I'm talking about if we were working with new distribution centers, we need to establish, how big those centers can be, And also we already produced a different analysis using, of course, the output from anyLogistix. We already did it. And also we already made some additional calculations for getting, that storage needed in 2031. And as you see right there in this graphic, you're going to see the actual capacity. And from that and to the top, we are going to check the storage needed, the additional storage needed. And what's of the important, let's say, outputs of this project, how to let's say, get this information from the whole modeling, and what was of the biggest, let's say, outputs we already presented to our customer. Okay, and let me show you all of these graphics. And as you see during this presentation, was made on Tableau. So we're not capable of doing those graphics on anyLogistix, and that's why we have to do it, externally. And we already exported the information and connected directly with Tableau, and then produce all of the graphics you are seeing right there. Okay. Then, besides this is increasing operation cost, also we already understanding that reassignment of production dramatically change, our supply chain configuration. And that will let us to understand how we're going to, let's say, propose a strategy for managing the whole supply chain. Okay. And let me show you the last part here, and in the last minutes I got, I'm going to show you this. Okay, so first of all, we decided to mix between, let's say, the findings we already got from the different scenarios and try to understand the better of them, and created a proposal strategy. Okay, we call this our implementation strategy. Okay, with that model, we already work with an additional network optimization experiment with that in order to make that comparisons between this and the baseline. This is our suggest model. And then you already notice that we already produce not so higher savings as we saw with the no restrictions model, no constraints model, but also, we already found some interesting points to be applied in a short term, for that company. So at the end, we already calculate, the total cost of ownership, the cost of serve, and what some of the biggest challenges. Let me tell you a little bit about that. Okay. So finally here, as you see right there, we already adapted the strategy because the company wasn't willing to close all of the factories. In the optimal strategy, some of the factories were closed, as you saw in the previous slides. Okay, but that's why we must add an additional constraint, which was a minimum production constraint in order to keep open some of the factories. Okay, then we added the new disease, and then we adapted the inventory policies, and that's why, and as you see right there, this is our final result. Okay, savings, yes, and something around 1 or even less than 1% of savings in the logistics cost, in the whole total cost of ownership, which you can see from a percentage perspective that can be a little bit low, but let me tell you that saving is huge from this industry. So we're already so happy to provide the company, the customers, with a really interesting solution that can be implemented easily in the short term, and also explain them how to control that strategy in time. Okay, so let me show you a little bit about that with this slide. So finally, we already calculate that. Let me take that opportunity, just to mention a little bit here the people from anyLogistix, and that gave us a really interesting support on it. But hopefully in the following versions, anyLogistix can provide us with a tool, let's say, for doing this calculation, the total cost of ownership. I know that this is quite challenging, it's quite difficult to calculate. And that's why, I want to let's say, to mention that before finishing this conference. Hopefully, guys, consider this for the following versions. Try to a way to calculate the total cost of ownership. Okay, and our calculation already saw, quite interesting results right there, as already mentioned previously. Our suggested model in every single department practically speaking, in every single department, creates a better responsive strategy for them, as you see right there. This cross element right there is related with our cost, and the total cost of ownership in every single department in Colombia. So what we were so happy with the final results, because at the end we already achieved our goal, in a really, really challenging business case, in a really, really challenging project. So I want to end with the following lessons we already learned, from this case. First of all, try to focus on total logistics costs and not only on transportation and production. That lets us to find a way to improve the supply chain strategy, balancing services and costs. That's quite important, focusing in this case on the total logistics cost, take into account that. Okay, for companies with multiple factories, sourcing strategy must be included. Another key lesson learned from that business case. On the very beginning, this project defined the scope from factories to end consumers. But at the end, with all the numbers, with all the analysis we did, we noticed that, and we recommended in that case, including always, if you are managing, let's say, a project with multiple factories, the sourcing strategy. That will lead you to change completely the supply chain network configuration. So we highly recommend it to take into account that, to consider this, okay, in projects like this. Inventory policies should be differentiated between product category and even by DC. This is quite important. I mean, you don't need to take, or you don't need, let's say, to manage at the same way inventory in every single distribution center, even if you are managing different products, if you are managing different demand levels, and so on and so forth. Okay, so that's quite important also. The network needs main DCs and some small ones for improving the service levels. Could be an interesting strategy that can be tested in different environments as well. And the last one, the transportation operation should be quite flexible in order to answer to production challenge. In that case, the key driver was the production itself. So we must adapt transportation accordingly with the production needs in order to create a better supply chain strategy, in order to create, in this case, let's say, a better way to behave. Okay, guys, well, that's it. And that was our business case. And let me give you one last highlight, for managing this project. And I finally work with an excellent team here, and leading with our director, which is Nelson Mariño, who leads that project to finally, achieve the goals we stated at the very beginning. And here in the Decisiones Logísticas, where they got an amazing co-workers, because that case can be possible. That solution that we already achieved here is just possible if you work in a really interesting team. And fortunately, I have the luck, let's say, to work with an amazing team here in the company. Okay, well, guys, that's it. Thank you so much, Ryan. Thank you so much, Daria, for this opportunity. Let me finish. Okay. And let me check the questions and answers pools, because he will have to switch a little bit between the question and answer and the chat. Let me see some of the questions right here. Okay. Okay. Well, I have a question here. Why was it more expensive to service Bogota? That's an interesting question, Jonathan. And there are two main things right there. One is related with the way that the city is located. In this case, I'm talking about the altitude of the city, which is 2,600 meters. And that means transportation is even costly. You need different transportation vehicles, and the consumption of fuel and everything related with that is a little bit higher. Okay, that's one of the main reasons. And the second reason, why Bogota is, for some products, not all of them, but for some products is even costly, is related with the way the city behaves. It's in the middle of the country, so it's far away from everything. Bogota is located precisely in the middle of Colombia, which is pretty far from the ports. From Buenaventura, we already have ports in the Pacific Ocean, and we already got ports in the Atlantic Ocean, but we are pretty far away from them. that way. And another reason why, Bogota is quite expensive, from logistics perspective. And also because here in Bogota, we already got the biggest service industries, but not the manufacturing ones. So most of the manufacturing companies are located pretty far from Bogota. So and that's another way to see why is quite expensive. Let me check here. There is one slide, baseline logistics cost, which is 9.2 in 2024. The new factory begins to operate. How to calculate this 9.2 baseline logistics source? What are the inputs data for calculating this? Wait, what we did there, was using, let's say, the network optimization experiments, and the input data was related, of course, with the demand and the warehousing cost, the inventory cost, and the fixed and variable costs as well. I'm talking about the warehousing fixed and variable cost, and should be taken into account, and also the transportation cost as well, where they calculate this on a ton basis. That's why we're our main unit, for managing the whole modeling thing. So we're taking into account these elements we need to work with. And also we establish, let's say, a common cost base, kind of establishing the same transportation cost for the whole planning horizon, and change a little bit the fixed cost and variable cost according with the volume we want to move through those distribution centers. Let me move here. Okay, I think I'm not seeing more questions in the chat. Let me move to the if there is any question here in the question and answer pool. Let me check, please. The model used a lot of input data. What tools for data preparation and creation of derivative scenarios did you employ? Thank you for that question. That's yes, indeed. One of the biggest challenges we faced was that precisely. Let me give you some ideas about that. In the real fashion, and even biggest companies, doesn't have the whole information perfectly prepared and everything you need just ready to move into a software like anyLogistix and just, let's say, doing the modeling in a really fast way. No, not at all. So for managing these preparation elements, we must work hard, really, really hard. Primarily, we used Excel, for doing this preparation information, and also some databases as well. But also we use some software like Tableau for understanding a little bit the insights, the information already presented to us, and was one of the biggest, let's say, challenges we already faced during this project. Getting the data, managing the assumptions we really need, for getting everything in motion, putting everything the right way. That was a really interesting challenges. So we already prepared that data using primarily Excel, for doing this. Get another question right there. You mentioned that production costs affect the final distribution. In your experience, it is common to focus in local optima instead of global optimization? Well, that is an interesting question related with the way we consider the supply chain cost. Okay, in that case, I highly recommend it to focusing on global optimization than local ones. Precisely, focusing on local optimization lets you to, let's say, to wrong answers. Probably you are not seeing the whole landscape. If you are not seeing that, probably you are not controlling the process, and that's why sometimes companies like this company we work with, already let's say, got some issues related with inventory, transportation, because we already, let's say, define a policy, an inventory policy, but they are not considering what's going on with the previous echelon into the supply chains, with the suppliers stage. And sometimes happens that the supplier stage is not capable of fulfilling those needs. So we are experiencing some kind of a bullwhip effect, in the whole supply chain. And that is happening if you are focusing only on local optimization more than global optimization. Okay, what is your approach for modeling storage space requirements? The model seems to use yearly time periods, so the product storage alone are probably not enough to represent the inventory levels correctly. How do you account for seasonality of agricultural business? And excellent questions so far. Here we are working with the aggregate model, and we defined these storage space requirements on aggregate level. And yeah, of course, there is a seasonality, present in the agricultural industry, and that industry is not, let's say, different from that. And we already, let's say, defining those requirements based more than production capabilities than, let's say, in this case, the raw materials sourcing strategy. Okay, and we did it in an aggregate level. Yes, because we are not, we didn't work with simulation in order to get a quite interesting effect from that seasonality. And we decided to do it just from an aggregate level in order to get a whole, in order to get, let's say, a kind of a big picture of it, and offer our customer an idea on when and how should change this space, the storage space requirements. Okay, so we did it on that way. Let me see if I can see. I think I'm not seeing more. Okay, yeah, well, you can help me, Ryan. I'm not seeing more questions so far.
I think that's all the questions that we have for you for now, Enrique.
Okay.
But, such a great presentation. Thanks very much. A lot of details.
Thank you.
And, answering the questions with so much information, but everybody will appreciate it. I'm absolutely sure. So,
okay.
Thank
you,
you,
Ryan. Thanks a lot. And thanks to Daria for all the support once again.
Sure. Hope to see you soon.